Now we have three types of EKG machines or ECG machines that we can use. We have a standard, and that standard comes with 12 leads, 10 electrodes that are placed on the patient's body. However, they do record activity from 12 different angles. We have a 3-lead ECG that monitors 3 leads at once. And then in emergency situations, you may see a 1-lead single channel being utilized. So a 12 lead is going to monitor 12 leads, 3-lead monitors 3 at once, and the single channel will monitor just 1 lead at a time. This is what your standard ECG would look like. And you can even see that we're getting a reading that's starting to print out from the ink stylus in the machine, giving us the patient's heart rhythm and results. Now with the electrodes, what you will see is that you will have all of the electrodes that you need in order to perform one test on one strip. So you'll pull one strip from the package and all of these leads will be used on one application. The electrodes are placed on the patient, and then they're also attached to what's called leads. You can see some of the leads here. Now with the leads, we're going to have what's called precordial or chest leads. There are 6 precordial or chest leads. We also have limb leads. So there is 1 electrode placed on each arm, 1 electrode placed on each leg. And if you do the math there, 6 precordial chest leads, 4 limb leads, we have 10 leads all together. Inside the EKG, it has its own type of EKG paper. You can see the paper here measured by what's called vertical axis as well as horizontal axis. Now, vertical axis is measuring the patient's gain or amplitude going up. Horizontal is all in measurement of time. So as we're measuring the time, we're also measuring the force in the electrical activity. This electrocardiograph paper is heat and pressure sensitive. And how the results print out, it uses a stylus that actually warms up to be able to create this ink for the reading. Because it is warm and it is ink, avoid pressure by fingernails and other objects. We don't want to smear or alter the results. And it can be displayed in graph or dot matrix format with vertical and horizontal lines. In that horizontal line here, notice that each large box represents 0.04 seconds. Each large box, 0.04 seconds. Now within each large box, you will also see smaller boxes. But if we're only counting large boxes, 0.4 seconds. In our example here, we have 5 large boxes. If we have 5 large boxes and each one accounts for 0.04 seconds, then we can say that from this bold line to the completion of this bold line represents 20 seconds. The reason again is because each small box represents 0.4, and we have 1, 2, 3, 4, 5 boxes. 5 times 4 would give us 0.20 seconds. That's going to be in relevance to our horizontal axis measuring time. Now going up vertically, we're measuring gain or amplitude. And if we're measuring gain or amplitude in the vertical axis, each one represents 0.1 millivolts. So each small square, 0.1 millivolts. So just to refresh, horizontally across is going to be time, vertically going up is going to be gain or amplitude. Also on your EKG paper, as your results start to print, you're going to see what's called a calibration marker. The calibration marker will begin or end your EKG rhythm. It does look like an upside down U, and it has a 90-degree angle. Now there are what's called universal standard calibration measures, in which we really don't alter any of the settings on the EKG, but we would want to verify that we're falling within these parameters for an accurate reading. You can see here that the gain or amplitude will change if the calibration marker is not as it should be. So our universal standard calibration measures would be 5 millimeters wide by 10 millimeters tall. This is representing the standard settings of a 25 millimeter per second paper speed. 5 millimeters wide by 10 millimeters tall. Settings of a 25 millimeter per second paper speed, which is standard for calibration of an EKG.